Hi everybody, and welcome to Spokane, Washington. The Geological Society of America meeting took place in downtown Spokane 3 days in a row, Wednesday, Thursday, Friday, and the video you're about to see was filmed on Saturday and Sunday, the weekend after the meeting. And we had a rare opportunity to get all of the Ice Age Floods geologists that you know from watching the recent Ice Age Floods A to Z series. Got them all together. Spent 2 days visiting sites, field sites, that Bretz and others were discussing. And the theme was, can we find some till, glacial till, that Bretz was sure proved that ice flowed over the city of Spokane? Spoiler alert, none of those outcrops were super convincing, but many in the group were intrigued and are still open to the possibility that there was an older ice advance over the city of Spokane. So I hope that you enjoy this video, which is just eavesdropping in on a combination of conversations between these experts, and it was a real fun thing to do. Special thanks to Google Earth by Glenn Cruickshank, who organized the whole thing and spent countless hours selecting the sites for all of us geologists to visit. Hope you enjoy the video. Thanks for watching. Let's go. Hi everybody, and welcome to Mondovi, Washington, just north of Mondovi. The Mondovi Horseshoe, as a matter of fact. And you're looking at a group of geologists: Jim O'Connor, Jerome Lesemann, Skye Cooley, Vic Baker, Glenn Cruickshank, Richard Waitt, Skye Cooley, Ralph Dawes. And we've been spending most of today, Saturday, Ralph Haugerud as well. And this is a site. Glenn? Would you mind reading to our viewers Bretz's comments here, Glenn? This is one of his sites that he had till.
This was indeed a Bretz site. At the south end of the Steel Arch Bridge, we're sort of at the north end right now,
Yep.
but 3 miles by road, northeast of Mondovi, is till in a road cut. Though the matrix is composed of much decayed material and there are many pebbles of decayed basalt in it, there is also many fresh-looking femag and fluosphatic pebbles and cobbles. No doubt as it to being glacial till, though no striated fragments were found. Unglaciated Pluce Hills immediately south. And then Flint says, same spot,
Yep.
in the road cut, 2 feet of stony grit in Palouse soil like matrix, rests on Palouse soil and overlain by 2 to 3 feet of superficial loess. So Flint and Pardee were both right through here, Old Road over there. And this is basically the same elevation as the across the way.
Thank you. So that was Bretz in the 20s, Flint in the 30s. You said Pardee. Did you mean Pardee?
No, I meant
Bretz.
Flint and
Bretz.
And Bretz, yeah.
Thank you.
1923, yep.
There's charcoal in there, but it might be young.
What do you see here, Skye? Anything? Anything look like till? Anything look?
Well, till wouldn't be the first thing I'd see.
Would not.
No. Oxidized, fine-grained stuff below this stone line, and then a gray, obviously younger sediment above. But till, I don't know. It's not very compact. it sure looks alluvial to me, but we're here at the mouth of this canyon. These hollows today are here at this dendritic upper part of this canyon. I don't know.
Right.
Till isn't the first thing that jumps to mind.
Fair enough.
Well, he's talking about the 2 or 3 feet of look on top of the 2 or 3 feet of blue soil. So it looks like there's.
Looks like we're in the right spot.
Yeah.
Sure. So there's a hard white zone through here, right? Starts at that stone line. But this is considerably older than.
Looks like it's definitely sawn wood.
A stone line. And you're clearly in what looked like should be Palouse, except that you have deeply weathered material. And so one idea is that you have some kind of old regolith, perhaps mixed with loess, that's developed on the Columbia River basalts, which after they were emplaced had a deep weathering profile developing on them. And you see that in the northern part of the plateau. So one possibility is that this is related to both of those things, the deep weathering of the basalt and early emplacement of the Aeolian loess material. The stone lines are what generally were called the Excelsior gravels, and they may have been emplaced by some kind of process from the north. One possibility is that they came across where we now have the entrenched Spokane and Columbia rivers. Prior to that entrenchment, that those materials were brought across. Here we just have basalts, but in other places we see the Okanagan Highlands materials. So something had to bring those materials across. If it wasn't glaciation, then it must have been some kind of fluvial process from the Okanagan Highlands, and that could only have occurred before the entrenchment of the Columbia and Spokane River. The other idea is that there was some kind of glacial action, but it wasn't what we generally conceive of as a ice that was emplacing a till at its base because of warm-based ice flow. So an idea that occurred to me from my work with Russians in Siberia about 30 years ago is that when you had lakes like Glacial Lake Spokane and Glacial Lake Columbia, that the ice coming in from the north could have produced ice shelves at its margins in the ablation zones of the ice. These ice shelves would have pushed across the water body. They could have impinged on the plateau, and they would have been pushed forward by the glacial action, but they would not have behaved in quite the same way as active glacial ice. There would have been a lot of melting in place as the glacial mass balance sort of went in that direction. So you would get a lot of things that were related to stagnant ice decay. That would include a lot of water related activity. And so some combination of what I just talked about might also be possible. This is a kind of a complicated idea, but clearly what we see here is very different than what we see further south in the Channel Scabland and what gets talked about in the classic story of glaciation to the north and cataclysmic flooding to the south.
So if there's some ice history, you're not saying for sure ice history here, but if there is this ice extension down here, it has to be far older than the last glacial maximum if it's before the entrenchment
The
idea.
deep weathering is clearly indicating a great age, and the association of the so-called Excelsior gravels with the deep weathering profiles, that implies considerable age. What I just pointed out, of course, is famous from one of Bretz's professors, Thomas Chowder Chamberlain, who was the advocate of multiple working hypotheses in geology. For him and for Bretz, the hypotheses were generated from nature itself. So you look at what you see in the field, you try to think of what would explain the oddity that you find, and that's not necessarily the explanation, but it at least is providing you with a plan to go look in other places for other things that you might find are consistent or go against that idea. So it becomes part of an investigation, and Bretz was a master at that.
It was. Thank you, Vic.
I think it's kind of a cool exposure. It could be cleaned up with this.
Yeah. Kind of an alluvial fill high in the wood.
Yeah. Because we
Well,
got
or
Scamland
just-
right up, I mean, we got all around bare.
We're in a little valley, so you'll have slope material moving down the valley.
Yeah.
I mean, you could flip it around and say if there's till in the landscape, typically tills and valleys tend to be thicker.
Yeah.
Right. But if that's the thickest we can make it here, how thick can it be up on the uplands?
This is a skiff of something.
Yeah. Skip of something diamictic maybe.
It just feels like it's related to the valley to me, even this
Yeah.
modern chain.
Well, as we drove to here, it's all bare for a good while, and then it sort of gets to be in sort of these rolling hills of less.
little remnant of the past.
Maybe he was just picturing the driftless area number 2.
Yeah.
Maybe that was his frame of mind.
Search image. Those
don't know.
black pockets and streaks are kind of interesting. Looking at- Yeah, that's redox features. Stuff is all modeled.
It's perplexing just because he's so clever about every other field observation and connection that this just seems like a real surprise that something that is presumably kind of
So that's charcoal. I
simple to
think.
tell. Yeah. But
He's
he-
saying this is definitely till. He just is
Except it's
lacking
missing-
striated stones.
It's missing arguably the most important smoking gun characteristic you would expect to see to make the case.
Well, it's not
It's that
particularly
ex-
compact either.
No, but we can work around that, right? There's different ways we can explain that. That's okay.
That's the compact.
I know he does, but no. But we found stones that are more convincingly till
Yeah,
at the first stop
right,
compared to these here. So,
right.
and the position of this is just it increases the odds that it's probably just colluvial material. We're in a little depression, a little valley, and a little hollow. There's material blowing in with silt. There's material accumulating here. There's slope wash when it's probably raining. There's all kinds of things that could be happening to produce these mixture. I mean, really, the only zone in here, anyways, that it might be is 40 centimeters. It's that stony layer
Right,
with a silt around it.
right. So it's mid-afternoon on Saturday.
Yeah.
Maybe you're the most sympathetic to, or the most imaginative or open to the idea of an ice advance this far south
Yeah.
out of this group.
Yeah. Maybe.
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 What have you seen? Have you seen anything that excites you or
Yeah. There's some interesting.
disappoints you?
I don't know. It disappoints me. I think it's more just trying to think about. The fun part is trying to put ourselves in Bretz's
Yeah.
thinking model or thinking framework. So the problem is sort of the same as around Spokane, is that there are patterns in the Less that are a little bit different south of here, where the Less is more deeply rilled and incised, and north of these zones it's a bit more subdued, but this, so you could make the case that it's ice advancing over the Less and sort of reshaping pre-glacial hills of Less. But the confounding element is that those areas also correspond with the highest flooding surfaces. And so can we trim those Less hills with floodwaters? Right? So,
Young floodwaters.
yeah, well, whatever age floodwaters, but yeah, presumably even young floodwaters. So that's exactly the same problem we had for the Cheney area and the airway heights, which is, was there evidence for ice being there, but the floods just wiped it all out, and so we don't know, or we can't tell. We've got two possible mechanisms. I mean, incidentally, I don't think it's hard for ice to cross the Columbia, because the Columbia lobe is often mapped as having crossed the Columbia. The height of terraces we were looking at are really high on the valley sides, which means that if that's a valley fill, it's not like the ice has to enter this deep trough and come out of this deep trough. It's actually just, it's not a big, there's no substantial, topographic obstacle for the ice to cross. It's just, is there enough ice to cross the Columbia in that specific locations, yet it's doing it at the Columbia, with the Columbia lobe, potentially. And then what does it leave on the landscape in terms of any evidence we might be able to see? So I think it's an open question, but the conundrum for me is just how this seems to be really out of character for the way that Bretz typically, recognizes important aspects. This is sort of seems like a miss in a way. That sounds a bit.
No, I'm with you though.
It's a bit cavalier, but you know what I mean. It's he makes so many incredibly clever and astute observations and connections, and this seems like, what happened today on that day between the Mondovi horseshoe and this one? We're just stumped, right? I mean, we can't quite we can't reconcile observations and what we see and what he may have seen and what is interpreted and described. So it happens.
Although Ralph Haugerud just has something here.
So you have two,
Nice angular chunk of granite.
Yeah.
Angular chunk of I'm not sure what.
Yeah.
The quartzite, the rounded quartzite sphere was too big to dig out of the outcrop.
Okay, so there's
Really?
Yeah.
Okay.
Yeah. So we float them in like this morning. Like the striated, bulleted shaped boulders. We float them in because we're near the high water flood marks. I mean, not far from here, we start entering the flood channels. So, yeah.
Well, you knew my private hope. My private hope
I know,
is sometime we would get to an outcrop where
you
are dead ringer. Listen, I'm from British Columbia. This is what till looks like. Or whatever, and then
so
others
far,
are
no
like,
such luck.
Not even close
No,
here.
not even close. Not even close. But what you're describing and hoping to see, you would see across the Columbia.
It's over there.
Yeah. It's over there. There's
Everybody in this group would go over there and see it and agree it's till.
There's a big moraine at Springdale, north of there. I mean, there's some outwash in the custom, but you can find outcrops of till or exposures of till.
And they're clearly 15,000 years old or thereabouts.
Most likely.
They're red, yeah.
They're
13 or whatever old it is.
Whatever number we put on it. It's somewhere between 13 and 17.
Yeah.
So it does exist. It's just not here. We're not convincing me here.
Thank you.
Skye, how old is that stuff you're digging
This is sort of a dirty.
Check this one again.
Uh-oh.
That's a good, your expectation of a bullet-shaped class in till would look a lot like that. It does have scratches. But who knows?
Well, he missed that one.
I don't know.
Or he wanted boulders that look like that. I
Yeah.
guess.
Well, but you can have,
Right. Huh.
Up down to that stone line. Yeah. This is lustier than I thought. Nice cicada burrows in this, but it's not really cemented back here.
You should go pick this along the way. This is a quartzite.
Okay.
I'll keep that one in my pocket for the next stop. I'll show it to you again. But I'm not panicking yet. We're still in my margin.
I have one bullet.
We got
I don't know if it's a concretion or not. I don't know what that is. It's a volcanic. Hey, Ralph,
We didn't see that.
what do you think this is?
That's all.
Ralph Dawes, Wenatchee Valley College.
What kind of rock is that?
Well, presumably the
Looks like,
historically.
well, it looks like it has a piece of gabbro and it looks like mixed piece. That's what it looks like, or else it's Ambrix Partusa.
It's not a tephra?
I don't think it's a tephra. Like there. Oh, so you got? Is it making a horizon, a horizontal layer?
Yeah,
Well,
it is.
so okay,
Guy, you got a
Kind of
tephra in the
flaky.
list?
maybe.
Get somebody over there who knows what
No, I see what you're saying because it's broken down into clay, but it has some little crystals in it. You think?
it's.
We have Richard Waitt. He knows what tephra in the list looks like.
Hey, Richard. Not a cloud. It's at the stone line.
It's at the stone line.
Yeah, it is.
It's just.
Oh, I can't see anymore.
Can you look at that, Jim?
Ooh, wow.
Tilted thing.
The gray.
One idea, but unfortunately,
This is-
direct evidence either way. Yes, erosion doesn't. So yeah,
Well, pieces up here.
Yeah. Holy cow.
I think it's tough. Got decomposable pebbles.
Yeah, I didn't get tephra out of this.
Is that just differentially weathered, or is
That look like tephra, Rick?
No, it doesn't.
No?
I don't think so.
Okay.
But I can't tell either.
Uh-huh.
So you're wondering if this is possibly a tephra?
I don't think it is.
Skye's thought.
Yeah, I mean, if it is, it's
Sand layer.
totally weathered through. You can see it up here too. A little piece of it.
Yeah, it's got some bigger clefts in it. But
This is frozen to the ice, so
Yeah.
this thing
Yeah,
is gonna
that-
go
that's-
up and down on the ice. So either it's frozen to the ice, and it's being dragged through the till at the base, and so you'll abrade the bottom, and you produce a bit of a like a boat keel, or the frictional resistance is high enough that you jam it in the till, and then it decouples from the ice, which means that the ice slides over it and abrades the top, which is what's producing that tapered shape, and sometimes a bit of refreezing. You can pluck the far end, but you'll get striations.
It's a canoe. This is a canoe. No keel.
Sure, yeah, because it's actually not moving in the river of till. It's just this. Yeah, that's like the perfect combo. You get all those parts. Three bits.
Right, so our next,
Well, Mondovi Horseshoe.
Mondovi Horseshoe.
Not as lucky as we thought it would be.
You found a striated boulder.
Yeah. I mean, and there are some pretty angular chunks of crystalline rocks, and Bretz does describe the FEMAG, so the ferromagnesian rock, the salts probably, and then the felspathic ones. So that holds. They're here. We see them all over.
yeah,
How did they get here?
yeah. This is.
Did we float them in?
Yeah, I mean, we're all that's solid basalt right up there.
Yes, exactly.
And basalt outcrops over there. So we're kind of in
Yep.
between the two outcrops.
Yeah.
And two layers.
So some of the descriptions hold. Others less clear.
The next stop, a couple things. One, our route out of here is going to cross some of his original channels. So kind of keep your eye out as we zigzag around through this next section, because there's the big channel we're going to cut across, two channels as we.
Scabland channels?
Yeah, these are Scabland channels. This is Bretz's original map.
Oh, okay.
So you are here, and then we're going to zigzag across these two big channels.
Day 2. It's a Sunday morning. Lydia Staisch is joining us from the USGS today. Otherwise, same cast of characters. This is near Medical Lake, Washington, and we have some outcrop that Bretz was studying. It was thought that this was correlative with the Cheney till, which is older than the Spokane till.
There's an article clipping somewhere saying that the brick factory, I think, shut down, or they made low quality brick.
Okay, that makes sense.
And and some of the descriptions, I think it's enlevered as a clay bed in the silt in the less, which would be this. But generally, the quality of the bricks was pretty small.
There's rocks all through it. It's kind of a junk pile. I'm a little surprised. Yeah. So this is. What do you want to know?
What's here? What do you see?
Okay, so deeply weathered profile here.
No, I can just
That's-
that's okay.
That has a variety of little of clasts in it, and so there's white quartzites that are well rounded, that are kind of in a stone line at the top of this deposit. And as we move down, we pick up these cinder, really deeply weathered cinder, probably of basalt origin. There are a few harder basalt clasts, but for the most part, the rocks here are incredibly deeply weathered. You can just almost pull them apart. So there's a deep weathering profile with some age to it.
Which simply led these guys 100 years ago to think this was a far older
A
deposit.
clay-rich deposit that brick factory apparently was probably mining pretty low-quality brick. But this is very clayey stuff. This is more like the Palouse near Moscow, where you have high rainfall. But look at that. I mean, you can roll a clay ball, no problem. There's a lot of clay in that, which is different.
Does this surprise you that it's here?
It does. This is different than the Palouse, and it doesn't feel very till-like, but it certainly has a unique character to it. A lot of clay. It's not particularly compact. You know, this doesn't feel like it's been loaded.
Well,
But it is an oddball. Yeah. The class composition, there's some granitic bowl quartz in here, and then those quartzites, and basaltic stuff. So
Well,
it's different.
We're south of Spokane. What here tells us we're close to an ice margin, if anything?
I don't know. Every time I'm in Cheney or Medical Lake,
Yeah.
it sure feels glaciated. I mean, it sure feels like there's some ice. There was some ice here, but maybe that's just the way this granite erodes differently in the scablands. I don't know. There's high less hills nearby, so I don't know how much ice would be here. Seems like any ice that made it this far south would have plowed everything out. And there's less hills right here. So it's an oddball. We're in a scabland tract. We got some odd deposits, but is this till? Well, that's a stretch. It's old.
It's old.
There's a
It's old, right in the middle of a frickin' scabland tract,
Yeah.
essentially.
right. Yeah.
Right?
I mean, scabland right there at the road.
Yeah,
200 meters.
right. I-90 is right over there with 4 lakes and a Medical Lake and all that thing, and here this.
Little remnant.
Well, I don't even get it, right? If that's a loose hill, and this is a scabland track, that's why this is surprising. How many scabland tracks have you been to where it's either loose or it's naked basalt with scab rock?
Well,
But you are looking for these older spots. This is
yeah.
did
this
you know about
eastern-
this site?
I didn't know about the site other than from the literature, and it's been this rumored, purported till in a clay deposit. So that's all I had known from
Okay.
from way back 100 years ago.
Yeah.
Reporting. It's interesting to see. It's certainly unique.
Might you work this up at some point on your own time to like add to your little collection of sketches of older exposures?
Yeah, I think there's another road cut there, and there's another road cut there, and there's
Yeah.
probably 5 or 6 others around. I think I'd see what I could see. It does feel like there's maybe a sluggish fluvial deposit on top of this, and then
Okay.
there's this weathering profile that's got angular clasts in it. There's a couple things going on here, but
Wow.
hard to say.
Pre-basalt landscape that it was deeply
Stuff does look old, doesn't it, Richard?
then started slowly eroding.
It's weird that you got relatively fresh ones and these extremely weathered ones in
Yeah.
the same place. You get the, as you've seen at other places, not very thick.
Fairly deeply weathered.
You know, I don't know what to make of these things. but-
Right.
Yeah. I mean, you can certainly see in the 20s how Bretz and Flint can call something like this till. I would have done the same thing probably. If it was me. You didn't have any real explanation there.
Right.
What about 2024? What do we do now? We still have that. There's some of the various explanations you could make for this. None of them really make sense.
Yeah.
If this were till, every place we've seen it, it's been fairly thin. Till is typically big, thick stuff, or at least
Right.
here and there.
Right.
And here, this is actually as thick as we've seen, I think.
Yeah.
We got maybe a meter here of class.
Right.
I don't know how far down they went. Yesterday we had just half a meter or less as a stone line. There are exotics in it. I think there's a quartzite over there. We saw some at the Iron Bridge yesterday. I don't know if everybody saw that big cobble-sized
I don't think I did.
quartzite, but definitely there. So how do you get that stuff here?
So-
You can't really derive it locally easily. You got no high. We're in a fairly gentle
the
slope,
context,
and
yeah.
there's nothing big high around us, or just sort
Right.
of shed down as a fan or anything like that. So how do you get them here? Well, the ready tools we have, in the way of explanation, the thing which seems to make the most sense, it would be ice rafting. But we're sort of making that argument at every stop we go to, and that would be a lot of ice to
Yeah.
raft.
Yeah.
In any case, these are weathered, so it can't be late Wisconsin. It's got to be something earlier. And we don't know that we've had any ice rafting, and we don't have any other proof of
Interesting.
this kind of thing.
I got a couple extra blue shirts in the car. We might have to put a blue shirt on.
What's that? What's that mean?
I got to update you on that color scheme. Okay. A little older than last glacial maximum. Yeah. Lydia, if you don't mind, what do you got there? I just heard an ooh over here.
Well, it's got a lot of green minerals. I don't know what they are exactly, but they're kind of a pistachio green. It could be like an epidote,
Oh wow.
possibly. I don't
Okay.
really know. But I was surprised by the color.
Totally.
But some kind of heavily weathered volcanic. I snapped it open with my hands. Interesting.
You're here for maybe a bunch of reasons, but one of them is the Upper Ringgold possibly kind of crosses into some of these older stories from the Ice Age.
Yeah, well, I guess we're looking for the evidence of these major river systems that we've seen to be traversing parts of the Columbia Basin, but we don't always know exactly where they've been located through time and space. And so anywhere where there's gravel, I'm kind of excited to see what it looks like.
Good.
This is not quite the rounded stuff I'm usually looking for,
no,
but still,
yeah.
nonetheless, interesting.
Excellent. Thank you.
As weathered as I've seen. Yeah.
It's got to be old.
Quite a little cinder.
This can't be late Wisconsin.
No.
Whoa.
So it's got to be. So it's certainly looking back.
You've got loess underneath, or a part. There's a component of loess there, so you've got, you're somewhere
We've
in
got
there.
maybe a half meter of gray, what appears to be gray loess on top, which is not unexpected.
Yep. but at least 2-meter thick profile of deeply weathered
Yeah.
stones in loess, clay rich, serious age. Certainly not late Wisconsin. But is it till?
Yeah, if it's not till, what other options do we have?
It's either fluvial or it's a lot of angular clasts in there.
Maybe we should come up with an Aeolian explanation.
High winds.
Yeah.
Very high winds.
I'm gonna get a camera.
So that one was kind of promising.
As a
Like-
till?
Well, just
Or
as old.
As old, yeah. I think
Richard
that's-
Waitt is talking pre-glacial, last glacial
I think
maximum.
Everybody else is, I think, and I think that is. Vic is saying that that's pretty typical of that so-called Excelsior gravel.
We didn't have that conversation yesterday.
No.
Nobody was clearly going to older than last glacial maximum.
Right. No, I think that's what
Uh-huh.
I think based on the weathering is where that's what very quickly brings it to that much older material. But then the question becomes, how do you emplace all that mix of gravels, rounded cobbles of quartzites, angular quartzites, basalt?
Got more. There's damn.
Yeah, more
quartzite
potatoes.
cobbles
More
everywhere.
potatoes.
So if it's not till, what other options do we have in the context of being out in this area where there's a loose hill nearby? There's the scablands right over there.
Yeah. So the question of this particular exposure, if this is really old, then where's the even younger less that we see elsewhere? So I think you could argue that probably some of that's been stripped away because we have scabland over there and there are floods moving through this area. So this is a remnant. So you got to think of a pre-flood, pre-late Wisconsin flood, or even before, stratigraphy that includes a surface of sediment that's covered in less, and then we have floods going through the Cheney area, the Medical Lake area, and we're incising into this less blanket, this right, and so this is just a remnant of that less blanket. So if we move in that direction, we're on the low part of a rising upland, and so the prediction would be that we get into younger less up here because there's been less erosion on those remnant uplands, because if we move in the opposite direction, then we hit scabland and basalt. So in the Vic Baker model of erosion through a less cover and focusing erosion into scabland and the basalt, this is just a remnant patch of that less cover. But it's an old it means that the less cover has a complex stratigraphy and a complex record, including very old materials.
Remnant orange, remnant blue, remnant purple,
green, you name it. Maybe colors that even never came out of the Crayola box yet. Who knows? So the question then, so that sort of gives you an option for explaining why that exposure is there and the way it looks the way it does. The next question is, how do you get the range of gravels and lithologies that are in there? And I was just chatting with Vic, and he's saying he's seen this kind of deeply weathered, occasional stone lines, concentrations, he said in some parts of Texas and arid areas. So long-lived weathered, what he calls pediment gravels.
Okay.
Right? And so it comes back to fluvial systems. Even Vic was saying perhaps when you first have the flood basalts covering the landscape before you entrench the Columbia, there's a more direct path for rivers that might be spreading, from the uplands that are now across the Columbia River, but prior to the Columbia entrenching its present valley, unimpededly, can cross the now Columbia onto the plateau and then distributing sediment, something like that.
Right.
But it speaks to this really, really long-lived combination of sediments.
Real exciting.
Yeah, it's interesting. They're different. It's the less hills aren't just less,
The
right?
less hills aren't
And they're not
less.
just late Wisconsin or Spokane age less. There's a sediment surface on top of basalt, which shouldn't be surprising because there are many millions of years between the last emplacement of the last basalt flow and the floods. Even the old floods, the 1,000,000 or 780,000 proposed floods. There's a lot of time there to do a lot of work.
Thank you.
Yeah, this is
Is that a quartz?
yeah,
Oh yeah.
probably a quartzite. What's interesting though is how do you get an angular quartzite? I mean, it had to come quite a distance. I mean, this is nicely round.
Beautiful.
Yeah. I gotta hide my damaged finger from your.
So you don't have your red bandana on right now. I mean,
No,
there's some
but I'm
pretty weathered stuff up there.
No, you know what though?
I think that covers the cuddling. Agree that.
The green. Well, so I have a blue bandana.
You do.
I do, but I'm not quite ready to break it out at this site.
I respect that. I respect that.
Oh. So, Jerome, you've looked at a lot of tills. Does this look like a till to you?
No.
No? Why not?
Largely because we're still stuck with the same problem of not seeing striations on clasts. I mean, we can incorporate all sorts of angular rounded clasts in till, but really, to be clear, we'd like to see some kind of striations, right? That'd be I'm happy with diamictin of some flavor.
Well, yeah, I mean, that's kind of a cop-out.
It is kind of a cop-out.
Because I'm interested in what in place fit here.
Yeah, exactly. It's hard to argue for slope material.
What's that?
It's hard to argue for that being a product of major. There's no slopes. So if it is really like if we wanted to make that argument, we'd have to see some form of striations on the class.
So you have to see striations.
Well, yeah. If you saw some, then it would be much more reasonable in terms of having that being a till. You can produce striations or scratches during debris flows and all kinds of other things, but we don't have the slopes to generate that. So if we saw striations, we could probably rule out that option, and it would really sort of push towards till more, but we don't.
It's hard to make this a fluvial gravel, though.
Very.
It's harder to make it a fluvial gravel than a till.
Well, Vic was talking about pediment type of gravels and the weathering being...
A pediment gravel is a fluvial gravel.
So he's thinking, I think he was talking about pre-entrenchment of the Columbia. River systems flowing over the plateau and moving gravel. But why are they angular?
Yeah. Far traveled class.
Have just a really wonderful.
And this, I mean, there's a mixed lithology in here.
Yeah.
Soil polish, not a water polish.
You know what? I'm going to solve this problem.
Oh, good.
There's an awful lot of silt maple.
There we go, making straight.
You son of a bitch.
Let me
You
see.
just did it.
Oh yeah.
He made a striated boulder.
Long way from
Perfect.
And the thick parts of the fans that would be coming off of those highlands are gone because of the entrenchment of the Columbia and the Snake. But the distal parts, which would include these gravels, that were in a climate that was allowing deep weathering and probably removing a lot of the mafics, concentrating the resistant material, would then be left on this early landscape. It's a mixture of deeply weathered basalt, maybe some aeolian content, and that landscape was then covered after about 2 million years by about 2 million years ago by Palouse loess. And these exposures are actually in streamlined hills of what one would have thought would be all Palouse loess, but it's got this older core. And so the late floods actually exposed that. But it's difficult because of the loess that slides on the slopes and covers the hillsides. So it's really tricky to find these exposures, and we're lucky we have this one to look at.
We are.
Yeah.
Well, I think this, Jerome? Yeah. Yeah, so there's a angular one right there. So see, maybe that one that he pulled out had slid down.
Yeah.
But the farmer pulled it off the field, so the stuff's here somewhere.
Right, but this is a flood-swept surface, presumably, because there's scabline over there. Okay, we're just on the edge of a remnant less island or mound.
I suppose. Geez, that thing's awfully big to be transporting over a surface like this. I don't know. Yeah.
So that would bring you
We just seem to be up too high and too near the rounded hills for something of that caliber to be. I don't know.
I'm not sure how else you get a big
I don't know either.
block of basalt up there.
I think we're still puzzling over this whole.
Yeah.
Some of this stuff is fairly old. I don't know about
Yeah, on that, so see that weathered basalt
Right,
with
yes.
the core.
Yeah, and all this, the matrix of everything is
Yeah.
weathered here.
Okay. Thank you.
So, Jerome?
Yeah.
So conceivably,
Yeah,
this stuff we see here
yeah.
is not the same as the
As the boulder.
that could be later. That could be from what?
Pleistocene
Yes, and they're sort of getting mixed here on
Yeah.
the slope.
on the
Yeah,
surface. I mean,
possibly.
If this is an erosional surface, then
Yeah.
right, we can have those two ages juxtaposed without
Some
problem.
of the stuff that looked in situ basalt, it's just angular. They crack it open, it's quartzite. There's a lot of quartzite.
Oh, really?
Yeah.
But the big one is basalt.
Yes, that's
So we're
basalt,
unclear. But
many
the
of
other
those-
one is quartzite.
Many of those, like the angular one by the
Yeah.
head of the hammer,
Yeah.
that's a quartzite. It's an angular one. It's not
Yeah.
rounded. So how does that get here? Unrounded.
Now look at this.
Oh boy.
Yeah.
Kind of look like.
Yeah. Well, but also
A plastic dike sill.
No stones down there. Right?
Stones, somewhat sandy. Look like
It could be bedding. It looks like it, doesn't it? More, rather than just weathering.
yeah, that's definitely not that's sedimentary structure, not weathering.
So that's underneath the stone bearing stuff.
Right. So I'm thinking swale. This whole thing looks like kind of a swale in the Palouse. That would make sense with this whole profile. But see, these are sluggish. Or are these rhythmite?
Jesus.
no, but they're
Backfill burrow. That's a thorough.
so
Okay.
here's another. That is just flood deposits. There's a boundary there. Let's scrape it and see what happens.
Oh, you
Right
son
here?
of a... Look at this.
Right, there's a boundary there.
Yeah.
And so the only thing against that is that it's so weathered.
What if we find rhythmite?
But you could incorporate all kinds of old clasts in a flood
You
deposit.
slept well in that truck. You are in full
Look at the
flower this morning.
bedding. Boy, these feel like water worked.
Oh my.
That's deformed, right? All this? Yeah, this is soft sediment deformation. Little dikes, backfill burrows.
It's not bioturbation.
This?
Yeah.
I don't think so.
No, you don't think so? I don't know. If this is really old, who knows what?
Could, but I'm just looking at, straight lines and then curving.
A lot of burrows.
This is what you need to do. Okay, so that's clearly bedding.
Wow.
I mean, looks like
Yeah.
very lake-like, not lake-like, but that could be in tushy beds, right?
Oh, you're opening a can of worms there.
Sluggish fluvial, little swale
Sure.
in the hills.
Yep.
Backfill burrows.
Yeah.
It's a little sandy. It's definitely sandy.
But go above. Scratch up above. Yeah.
This is that.
It's very different, right?
Stone line. Yeah. Oh yeah.
You see the
definitely.
boundary between
right
them.
there.
Well, no, here. Comes this way through here. This material
Yes.
starts here.
Irregular contact.
Yeah, and that's the coarsest. Anything below is fine.
Yep.
Anything above that is coarser and has the stones in it.
So a less slightly sandy parent here. Yeah, this is all different.
Yeah.
I mean, look at this. Well, that's wet swale. I was just
Sure.
looking for repetition.
Yeah.
How light colored that is, sandy.
Mm-hmm.
Yeah, tons of old backfilled burrows, old ones too. These are clay-rich fills. Just looking for repetition. If there was another stone line or another, need a better shovel.
So why can't this be a flood deposit?
Oh boy.
Oxidation, I guess, is the only thing that would hold us back.
Well, I mean, I suppose it could be a flood deposit, but
That would be the easiest way of incorporating angular, rounded, multiple lithologies all in one.
But there's absolutely no organization to it. At least that's apparent to me. And I mean, the last glacial flood deposits are
Clay throughout, but boy, there's some bedding here.
But if you imagine,
This is deformed above that layer, deformed up to here, all the way through there. And it kind of sorts itself out, thickly burrowed, heavily burrowed, and then this bedding comes in. So yeah, sluggish fluvial system.
I'm just saying that because there seems to be a boundary
Possibly
to what
something
Skye
else.
just cleared.
Sky.
Yeah,
What's
it seems like the
white
stones
stuff.
are above that.
Yeah,
superficial.
But
I think it's an old clast,
here,
or possibly a backfill burrow.
Exactly. So we're in the same dead end as yesterday.
Yeah, it looks like these are burrow fills, and they're just in zeolite.
It's like, oh gosh, it's like fuzzy. It looks like mold.
Yeah, it's like a
Yeah, it is more.
yeah. Old mold.
There's a piece of wood in it.
Very interesting. I think there's more here. Well,
That's really working this one. We probably got a pretty good exposure. I'm not sure if I can top this one right now, but this is it's neat that we found something that's pretty close to the Cheney till that's still available, and it's like I say, this is exactly the same altitude as Cheney, so it could be the same related things. We're sure finding that the quartz that I found at other sites are Excelsior sites are showing up here too. Those little rounded quartz gobbles. I got a whole box of them in the truck.
So Glenn, how did you organize this weekend? How did you decide to set the itinerary and which field sites? Is there a theme to all these field sites that you've selected for the weekend?
Well, partly to there was a mix of wanting to see old till, and that's we can find a lot of easy gravel, easy new stuff, but not the old stuff. So it's harder to find that. Yeah. Just because of who's on this trip, I wanted to get some Bretz sites in there for the historic purposes, and why we started at Pantops. That had to be the place that this group works.
Yeah.
But to get this group out, so a combination of Bretz sites, showing some of the Excelsior gravels, just trying to find these, and then be able to hit 5 or 10 sites,
right.
So that we're just not wandering around the country, get road cuts to make it kind of efficient. So just picking a destination and find good stuff along the way. And it's lucky that Bretz was everywhere, so it's not that hard to find a Bretz site that we're going to drive by. But the one we're going to this afternoon on the railroad crossing, though, is is unique, I think, in that Bretz describes a very specific boulder in his notes, and we're going to see that specific boulder, so that 100 years later we'll see exactly what he saw, and I think that's pretty cool to get people out and get this group, really the first group of geologists that have been viewing these Bretz sites, unless some people are doing it ad hoc, but not to this extent. So this is I wanted to get those historic sites in just to take advantage of Vic and Jim and Richard and the other team that has spent so much time on this.
Well, talk about cool. We never dreamt, did we, back in November, that we'd have everybody here in the flesh?
Right, yeah. This was not something we saw where this little episode was going to go, which then tells me who knows where it's going to go after this.
Right.
We've got lots of opportunities. So, this has got an unexpected way, but it's been an absolute delight to be able to get this group out here at this time to these sites. Yeah, we didn't see that coming.
No, we didn't.
But that's cool.
It's working.
It's working.
Thank you.
Yeah, it is absolutely working. So these guys are they're working this side hard. This
You're
is
gonna
real.
have to cut this one somehow. I don't know, but
Yeah, we can spend once we get our lunches, is put up a picnic table and sit here and start watching them work. And it's interesting them working, sharing their field craft back and forth, and
yeah,
we're breaking rocks on the road, and
good stuff.
and you've got a mix of generations too that are sharing that data. So
Pretty neat.
Pretty darn cool.
No, I mean just in general. You could have
Right, but we've got fine grained sediment exposed right there, right? Let's go look at that. Yeah. That's part of this sequence here. See that light stuff? Yeah. So that's so that boulder, probably not that boulder.